Let's now graph a quadratic. And so here are steps to graphing a quadratic. First, we want to determine if the parabola opens up or down. So let's just kind of go over these steps as we go over this third example. So if my third example is f of x equals negative x squared minus 4x plus 3, is this graph going to open up or is it going to open down? Okay, from last video, hopefully you know that this opens down. Why? We look at A, because there's a negative out front, because A equals -1, that makes it open down. So anytime we have a negative in front of that x squared, it's going to open down. Okay, the next thing we want to do is find and plot the vertex. Okay, that's also what we did on the previous examples. To find my x, we're going to use x equals -b over 2a. So my a here is -1. My b is -4. I don't need my c, but if we did, my c would be 3. So if I have -b and my b is already a -4, -4 makes that a +4. Over 2 times my a is -1. So we have 4 over -2. So we get -2 for my x coordinate. That's only half of my ordered pair for my vertex. Now we plug this in. Now be careful when you plug this in. My first term is -x squared. So negative from the negative here on this. And then what are we substituting in? -2 and then squaring it. So I've got a double negative here. First negative from my function, second one inside from what I'm substituting in. And then -4 times -2 plus 3. So let's see what we get here. And we get 7. So my vertex is at the ordered pair of -2, 7. So I'm going to go ahead and plot that. It says to find and plot the vertex. So -2, 7 right there. Now, that's a very high vertex because we've already established that it's concave down. I know that's my highest point, so that should kind of make sense. Then the third thing we need to do is find, graph, and label the axis of symmetry. Well, my axis of symmetry is just x equals my x coordinate. So axis of symmetry is x equals -2. So I'm going to put a dashed line through that vertex here. And we put dashed lines because this line doesn't really exist. It's just kind of here almost for graphing purposes. So we have found, we have graphed, and now I have labeled my axis of symmetry. So far, this is everything we did on that first page in examples 1 and 2. Now I get to part 4, and this is where it becomes new stuff. We need to make a table. The vertex will go in the middle. The other other x values should include numbers both smaller and larger than the x value of your vertex. Plug in those x values into your equation and solve for y, or use your axis of symmetry. Okay, so what do we mean by that? I'm going to make a table here. And I want 5 points total. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. First point I want to put in here is my vertex in that middle spot. So right here, we are putting in -2, 7 in the middle. This is my vertex. Okay. Part B, so that's what part A said. Vertex goes in the middle. The other x value should include numbers larger and smaller than the x value of your vertex. So it doesn't matter how big or how small, but I always go 2 up and 2 down. So 2 up might be -3 and -4, 2 down, -1, 0. And now plug these all in. So to get this coordinate here, we would now plug in a -4 for both of these x's. Then we'll plug in a -3 for both of these x's. Plug in a -1. And plug in 0. With all of these, where I see that x, I am plugging in whatever number I see right here. Now, if you have already plugged in this into your calculator, these are all insanely fast to do. Okay, here's where I plugged in my -2. I'm now going to arrow up and change whatever my x is to whatever I have here. In this first one, it equals -4. So I'm going to change these all to become -4. And we get 3. Arrow up, change these now to -3s instead of -4s. 6. I don't need to do 2 because we already found that to be 7 right here. So now I will do -1. And now I will do 0. Okay, so that table should be really, really fast because in fact, we really don't need to write all of these out here. I'm just doing it to show you exactly what we're plugging in and how we're substituting it in. But you really don't need to write these out, right? So this should be really, really quick. And if you notice, there's a pattern here. You have your vertex, and then 1 up and 1 down, we have the same number of 6. And then 2 up and 2 down, we have the same number of 3. And that's because of that axis of symmetry. So let's graph these real quickly and see what I mean by that. So we have -4, 3, -3, 6, -1, 6, and 0, 3. Okay, you can see here's my parabola. From that axis of symmetry, these points are both 1 unit away. They mirror each other. On this point here, these are both 2 units away from that axis of symmetry. And then you just graph. And you do want to make sure that that is curved up at the top. It is not a hard shape. It's not like a hard point. It is a U, not a V. So here's my parabola. Now, we're only going to do one example of graphing these by hand because what do we have? We have a graphing calculator. I can get most of this information from using this. So I'm going to go through this kind of quickly here. So if I go to my y equals and I clear everything out, and my y1, I'm going to put in my equation. So we have -x squared minus 4x plus 3. I want to match my graph that I'm given, and that's a standard. So I'm going to go zoom 6 down here for a zoom standard. And here is my graph. Now you can see it doesn't have that axis of symmetry in there because we made that as a dashed line because it's imaginary. It's not really there, but we're putting that in. And you can find this vertex right here if you find the maximum. So if I hit second trace to go to calc and I find the max, I want the left bound. So here's my max somewhere over here. I want to go somewhere to the left, hit enter. Now I want to go somewhere to the right, hit enter. There is my max. And again, I don't know why sometimes it does that, but that's basically -2 right there, which is what we got here, 7. And then even more helpful if we go here to the table. So second graph right there is my table of values. -4, 3, -3, 6, -2, 7, -1, 6, and 0, 3. So we can even graph more of these points if we wanted to, but we've got the points that we need to make this graph right here. So while it's, I guess, kind of nice to do it by hand, not entirely needed since we do have this graphing calculator. Pretty handy.